Okay, so I just wanted to do a couple more practice problems. I hope that you will pause the video, try the problem, and then watch me do it. So here we go. Um, Inside the box, I want the numerator of the fraction or the thing that I'm dividing up. So I'm going to start with putting the first term in the first box. I'm going to put x to the fifth here. And what I want to divide by is x plus 3. So then that's going to force me to put an x to the fourth here, which means that this has to be 3x to the fourth, which is good because that's what I want. So these two terms are both done. So I can say either I'm adding 0x to the fourths here, but that's not really that helpful because then the whole thing is going to be 0 there. And so I'm just going to kind of move on with my life and say, you know what, I'm done with the x to the fourth. So then next I'm going to do the negative 13x cubed. And so that means that I'm going to have my negative 13x squared there. And so then when I multiply this times this, then I get negative 39x squared. And now you're thinking, wow, this problem is starting to prove itself. It's going to be okay. It's not that bad. So now I've done this term, but I've also done this term just kind of by the way that it happens to lay out. And so now I'm done with this and I don't have to add anything else. I could add a 0x squared here, but that's not really doing much good for me. So I'm going to erase that and I'm just going to move on to the next term, which is 42 x's. And to get there, I'm going to need a 42 here. But 42 times 3 is 126. And so really, the box that I drew is actually too big. And so I could just make this go like this. Sometimes we need to add squares, sometimes we need to get rid of some. But since I match the 126 here and the 126 here, I'm done. My answer to this polynomial division question is the quotient, which is this part right here. And so you could say, when you do this division, you get this. Or you can say that all of that stuff, x to the fifth plus 3x to the fourth minus 13x cubed minus 39x squared plus 42x plus 126 is equal to x plus 3 times x to the fourth minus 13x squared plus 42. So that's the division problem, and that's kind of how we can interpret it. You try this one. Okay, I'm going to put my x to the fourth here. I'm dividing by x minus 2. I need to put an x cubed up here so that x cubed times x gives you x to the fourth. So that means that I have to put negative 2x cubed here, but I don't want negative 2x cubed. I want positive 2x cubed. So what do I have to add to get there? I have to add 4x cubed. So then, to get to the top of the box, I need to put a 4x squared there, because 4x squared times x has to give you 4x cubed, okay? That means that I have to put my negative 8x squared here, because that's what this times this is. Then I have to look, well, what do I actually want? I want negative 6x squared, but that's not what I have. So what do I have to add to get there? I have to add 2x squareds. That makes me write, I have to write 2x up at the top, because 2x times x has to give me 2x squared. So then, what do I get down here? I get negative 4x. Okay, that's not what I want though. I want positive 4x. So I have to add 8 x's there. Okay, And so now I'm almost done, but I'm not quite there. I got to put an 8 here because 8 times x gives me 8x. And so now I need a negative 16 here. And the plus side now is I'm done. And I know that I'm done because my last term, the last thing in the box, matches the last term of the polynomial that I'm dividing. So a little bit of interpretation practice here. What is our answer? Our answer to the division problem is the quotient, which is the top of the box. That's all of this stuff together when you add them together. What can we say about this? We can say, well, x to the fourth plus 2x cubed minus 6x squared plus 4x minus 16 is equal to x minus 2 times the stuff on the top of the box. So that's x cubed plus 4x squared plus 2x plus 8. Okay, so this is going to be really helpful for us in the future. I do want to show you one thing. And I'm going to do this one right away by myself so that you can watch me do this one, and then there will be one more that you have to practice. This is a situation where you might get a remainder out when you do the division. And maybe you remember doing quotient and remainder division from, like, I don't know, middle school, maybe even elementary school. But let's see what happens when we do this division. So we're going to set it up the same way. X minus 7 is what we're dividing by, so we're going to put that on the side of the box. I'm going to split it up like this. This does not have to be perfect the way that you draw it. It's all good. You're going to put your x cubed here. That means that I need an x squared up here. That means that I have to put a negative 7x squared here. And I do want that. And I don't want any more. So what do I get? I'm going to put, for our purposes this time, I'm going to show you what would happen if I wrote all of this stuff out. I would put a 0x squared here. That would require me to say 0 x's go here, which means that I have 0 down here, 0 x's down here, because 0x times 7, negative 7 is still 0. I don't want any x's because there are none written right here. And so I need to add no more x's, which means that I need a 0 here. I'm going to do that in a different color. I need a 0 here. And so then I need a 0 here to reflect this multiplication here. But this is the problem. I am at the end of the problem. I'm at the number without a variable, and this does not match this. And so the question is, what do I have to add to get to negative 2? And the answer is the remainder. And my remainder is what you have to add to get back to what you started with. So what I can say is x cubed minus 7x squared minus 2 divided by x minus 7 is equal to x squared, and then I don't really have to write these two things because they're both 0, but then I have to say remainder negative 2. I'm going to talk about what that remainder means. Here's the thing. There is this thing, and I'm not really going to be asking you a lot about this, but I just want you to know that it exists. This thing is called the remainder theorem. Okay, so here it is. When you divide p of x by x minus a, that's just a factor, like we did here. We divided our polynomial by this. The remainder r tells you the output of p of a. So what that tells you is if you put in a, if you put in 7 into this polynomial, you will get out this, negative 2. So what that says is P of X, I guess I should say it this way. The point A remainder is on the graph of P of X. So if you want to find a value for the polynomial at a certain X value, you can divide by its factor and use that to get the remainder. When you get the remainder, that's the output of the value of the polynomial at that point. It's not a super useful piece of information, and I'm not really going to be asking you questions about it, but I thought that it might be helpful for you to know. What this means is, I'll just show you a little graph really quick. This graph probably looks something like this. Here's where x equals 7, and this is the point 7, negative 2. That point 7, negative 2 is on this graph. One more with a remainder. I want you to try this one first. Here we go. Okay, I'm going to take this and put it here. I'm going to divide. I'm going to see what happens if, what do I get out here? I get an x to the third. That makes this 8x cubed. That's what I want. So then I can just, I have this, so I can move on to this term. Okay, so the next term that I want is negative 7x. That means that I have to have negative 7 here. And so then I have to have negative 56. But that's not what I have here. What I want here is negative 57. So what do I have to add to get to here? I have to add negative 1. So the remainder here, the remainder is negative 1. So if P of X is x to the fourth plus 8x cubed minus 7x minus 57, so P of negative 8 is negative 1 by the remainder theorem. So if you put in this value, remember this is x minus a, and since it says plus 8, it's minus x minus negative 8. P of negative 8 is the remainder, okay? So not a super useful piece of information, but I am going to be expecting you to be able to get a remainder out when you do a polynomial division. You don't necessarily have to be able to interpret the answer, but I need you to be able to get to the point where you know what the remainder is.